broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to our standard AMS webinar, monthly AMS webinar. We got a pretty exciting new topic today. It's called CAM automation, tips and techniques. And we are going to be talking about some of the new technologies we have implemented in our products to enhance automation. And so today's agenda, we're going to start with the basics, the tool libraries, how you set up tool libraries, and that's one level of automation. And then use of default parameters, how you can effectively use default parameters to implement automation as well. And then we're going to be talking about automatic toolpath creation using knowledge bases. This is stepping it up a little bit to use knowledge bases and the process information in your shop floor using that, encoding or embedding it in knowledge bases, and then using that for repeatable and automated CAM process. And then we'll also go a little bit into talking about how to select geometry in knowledge bases. Initially we'll just show you how the knowledge bases work, and then we'll talk about how we can actually select geometry into knowledge bases for control of machining. And then we're going to be talking about the SDK, or the Software Development Kit, from RhinoCAM. And then finally, we're going to be touch upon the Grasshopper, how you can use Grasshopper in CAM automation. For those of you who don't know me, my name is Joe Anand, and I'm the product manager here. And I'll be joined today by Don Lacoris, who's our senior application engineer and support manager. And what he's going to be doing, we're going to be doing a little bit different kind of webinar today. Don is going to be showing the first 4 topics, and then we're going to switch it over to me, and I'll be showing more of the programming part of this webinar. So a little housekeeping tips, so you don't have that. Anyway, so we normally like to keep this interactive. And you will see that chat window where you can add your questions in as we are progressing, and one of us will be watching those questions, and we will answer as we interactively. And if we need to stop the other person doing the demonstration, we can do that as well. And then if we don't get to your questions, we'll always answer it by email. And then, as usual, we'll get the webinar recording sent out to all the registrants. All right, so without any further delay, go ahead, Don.
Hello, everyone. Hope everyone can hear me okay. As Joe mentioned, we're talking about CAM automation. This is always an exciting topic to talk about because it saves you a lot of time in your machining process. I have the tool library automation slide up, but I want to step it back just 1 second and talk about template files, which I don't have a slide for, but I just wanted to mention it. You may know already, if you're familiar with Rhino, and the same is VisualCAD, is you can create a file and save it as a template file. And you'll find that in your files menu in both Rhino and VisualCAD CAM. Basically what that does is just any geometry, any layers that you want to have displayed. A lot of users actually have a base file that has like their spoilboard or a fixture that you always have on your spoilboard. They work that into their template file, so every time they create a new project, it's there. So that's just one base of one level of automation you can do without RhinoCAM or VisualCAD. Okay, with that said, we're going to be going a little bit slower than we normally do and see if we can get all this stuff in so that we can get this cohesive workflow through here. Okay, so we're going to talk about tool library automation. This, as you know, if you're obviously already working with RhinoCAM, VisualCAD CAM, you can create tools and you can save those tools. You most likely know that you can save a tool library. But what I have on the screen here is, if I start on left, I'm just going to name the dialogues and I'll go into a little bit more detail. On the far left, you see what we call the machining objects browser. It has 4 tabs: a tools tab, regions, features, K-bases. This is typically located at the bottom left corner of your Rhino display in the RhinoCAM machining browser. This is the bottom portion. And here's where you can load your tool library in here. And we're going to talk about this toolbar up here at the top in a little bit more detail. When you create a tool, obviously you use this dialog in the middle to define all your tool parameters. And what I want to mention here, the reason one of the reasons that we're talking about tools is that you can embed a lot of knowledge into your tools without really doing a whole lot of work, not a lot of setup or anything. When you define your tool, you're obviously going to set your tool dimensions, and you can set your feeds and speeds and the properties of the tool and some other options here. This knowledge gets saved with that tool based on the tool name, okay? So you can embed all this knowledge that you need for a certain tool when you use that tool, and then you can carry that knowledge over into your operations when you load that tool. And then on the far right, we have some cutting tool preferences where you can set some cutting tool colors, the display, and then your library preferences, what tool library you want to load when you start. Let's go to the next screen here. Now let's talk a little bit about, we're going to go over this in actual demo in RhinoCAM. So we're just showing you the slides right now. So using default parameters, as soon as you install RhinoCAM or VisualCAD CAM, it comes with factory set parameters. So if you just load RhinoCAM, load a part, and just create an operation and regenerate, in most cases in 3-axis, it'll just it'll analyze the part in the stock, grab the default parameters, and create a toolpath. And a lot of users do that just to get a toolpath on the part so you can look at it and then tweak it from there. You can save, as you define your parameters in an operation, you can save those out to a default knowledge base. And we'll show you how to do that and where that knowledge base is set. So on the far left, you see the Save as Defaults menu in the machining job. And then you see the Preferences dialog in the middle, where you can set your default knowledge base for default parameters. And then on the far right, you just see some other interface preferences that can affect how default parameters are loaded when you open or save files. And Joe, if I missed something here, just feel free to hop in. So knowledge bases in 3-axis. What you see right here is a progression of three files. If we look in the top left corner, we have a starting part that we're going to program with a roughing operation and a parallel finishing operation, and we're going to save that out to a knowledge base. And then we're going to load 2 other files and apply that knowledge base and have those toolpaths generate automatically. This is something that you can do in 3-axis that will totally automate your toolpaths, because in 3-axis, you don't have to select any control geometry. If you don't select control geometry, it'll calculate the toolpaths based on the part geometry and the stock geometry. You do have to have the stock defined, by the way, to completely automate it in 3-axis. So we're going to show you that, and then we're going to actually load that knowledge base and show you how to edit it and how that works as far as dragging and dropping operations from the knowledge base up into your machining job, etc. This is all in 3-axis. Now, in 2-axis, it's required that you make a selection of control geometry in 2-axis, because in 2-axis, it doesn't know that there's a part model per se. But you don't even really have to set your stock in 2-axis. But if you want to, obviously, if you want to simulate it, you got to have your stock. But in 2.5-axis knowledge bases, at the base level, if you want to implement a knowledge base in 2-axis, you do have to select some geometry for each of those operations. We're going to show you a fast way to select geometry when you use a knowledge base. And then we're going to bump it up a level in 2.5 axis and show you how you can automate the selection of geometry in 2.5 axis. So you can completely automate your 2.5 axis operations similar to how you do in 3 axis with automatically selecting your geometry based on layers or colors of geometry, etc. And then, like I mentioned in this slide here, we've already set our selection rules, and we're just dragging and dropping operations up into the machining job and generating them to automatically come up with a toolpath. If there's any questions, feel free to add them in the questions panel, and we're monitoring them in the background. So here is where Joe's going to take over in the last 2 topics. You want to talk about these, Joe?
Yeah, I can do that. The end of the webinar, we're going to be talking about the SDK and the Grasshopper components, as we said earlier. A little bit about the SDK. For those of you who don't know what an SDK means, it stands for Software Development Kit. So what that means is we bundle this software development kit along with RhinoCAM, and that basically is an interface to your programs, any programs that you write, that you can leverage our RhinoCAM functionality, and that's what the SDK allows you to do. And you can see the graphic on the right side that shows the different components that you need in order to leverage the SDK that's bundled with RhinoCAM. Obviously, you need Rhino, and of course the RhinoCAM plugin and the RhinoCAM SDK, which is actually built into RhinoCAM, so you don't need anything special. Once you install RhinoCAM, you're going to be able to immediately start using the SDK. And then, of course, you need the Python or C# program or .NET C# programs to actually write programs and use the SDK functionality to drive CAM. So the second topic, bullet item here says, yeah, you can use the SDK to create programs to automate CAM, and we'll see what kind of programs you can create later on in the demonstration. And we offered 2 kinds of programming interfaces. One, you can use Python, which is actually, for those of you who don't know what Python is a very popular and an easy to learn language that's very popular these days, and I think in the Rhino world that's used a lot in a lot of different areas, and so that we chose to use Python as one interface, the Python interface is one. And then we also have a .NET interface where for more advanced programmers, you can use the C# language from Microsoft and use the Visual Studio tools to create programs. And anything you can do in Python, you can do in .NET and vice versa. So they're kind of mirror images of each. So depending on what you're comfortable with, you can use either one of those interfaces. The SDK itself needs Rhino, obviously, like that graphic talks about. RhinoCAM 2023 should be installed, and of course you need to have a RhinoCAM 2023 license and as well as Rhino license to run the SDK. SDK is installed with the RhinoCAM, so you don't have to do anything extra. Once you install RhinoCAM 2023, the SDK will install, and the little graphic on the left side, the bottom left, shows the path name. A path where it's going to be installed is actually going to be in the program files, Rhino 7 under plugins. I'll talk a little bit about that when we jump into the demo. And then, to use this, the user would need expertise in programming. So this is not for the faint-hearted. You can't jump in real easily unless you know Python or say .NET, especially .NET, unless you're familiar with that. This won't be your cup of tea. So this is for advanced users or companies that have the expertise in-house that they can leverage this. But the power, of course, with the power, you have a lot of nice features that you can implement and automate your entire process in the shop floor. And we have companies doing that today. We have a large company in Japan who's taken saw machining, and they're doing all kinds of automated saw machining for lumber. And we have many instances here in the US as well that are using the SDK in different varying levels. All right, Don, next slide, please. Then we will talk about Grasshopper. For those of you who are not familiar with Grasshopper, Grasshopper is a Rhino plugin that is installed with Rhino 6 or 7. And by the way, the RhinoCAM SDK works also with the Rhino 6 or 7. Grasshopper is a plugin that's built into Rhino and is installed with Rhino 6 or 7. And what Grasshopper is, it provides the parametric design capabilities in Rhino using a visual programming user interface. So what that means is you can actually, instead of actually programming something, the logic of your program, you can do visual programming. So it makes programming a little bit easier. And since there are built-in components that you can drag and drop, a lot of those tasks, the programming tasks, can potentially be fully automated using Grasshopper. And then, and it's really, when you're getting into families of parts and things of that nature, let's say you're machining or creating panels, that might be an area where Grasshopper can come in very handy. So you're just changing a parameter here, and then it creates new designs. And then on top of that, using the Grasshopper components that leverage our RhinoCAM SDK, you can actually end up with parametric machining depending on how your design process is set up. So we'll talk a little bit about that. We're not getting, won't get too much into that depth, but we will talk a little bit about that in our demo. So, all right, Don.
Okay, we're ready to start the demo. Let's go ahead and I'm going to switch over to RhinoCAM. So the first topic we're going to talk, I mentioned template files, and I'll just talk about that briefly. As I mentioned in the slide, you can set up a file with any geometry that you want to be present on any CAM project that you start. Typically that would be fixtures or your spoil board, any fixture mounting hole patterns, etc., any layers that you want set. You can do all of that in one file and then just save that file as a template. And that's available in the file menu, save as template. Then when you create a new file in Rhino, it presents your file manager. It automatically goes to where the template files are and allows you to select the template to start with. You don't have to use the template functionality, but it's real helpful. Now, we're going to talk a little bit about tool libraries next. I mentioned in the slide, if you familiar with RhinoCAM, obviously you're familiar with creating tools already. Down here on the lower left, you have the what's called the Machining Objects Browser, and it has various tabs. We're going to be in this webinar, we're going to be talking about the Tools tab and the K-Bases tab, those two tabs. And let's talk first about creating a tool, what kind of knowledge you can imbue into your tool definitions. Obviously, when you create a tool, you have to give it some dimensions. You got to give it a unique name. Every tool has to have a unique name, and every separate tool. So then obviously your preview, but over here on the right, you can set some parameters specific to the tool, such as a material, and then some adjust registers and cut com registers, etc., for each tool. But in the feeds and speeds, obviously you can set all of these values, spindle parameters, the feed rate values for a specific tool, as well as some additional feed rate options for plunging, first XY pass, bottom level, etc. And you can set a cut depth, a maximum cut depth for a tool, and you can load those when you create an operation. So you can set all of these parameters, okay? And you can also put comments with the tool, etc. So when you save this tool out, all of this information is embedded in that tool definition, so that when you use the tool, drag and drop a tool or load a tool from the Tools tab, all this information is being carried over if you choose it to be. So let's go ahead and I'm going to just close this for a moment. And let's talk about, we talked about the toolbar. Let's talk about this toolbar right here. We did the create tools. You have additional icons here on the toolbar for loading a tool library and for selecting a tool from a library. So let's just go ahead and do that. And you can drag and drop a tool into your working session that you want to use from your library.
Hey, Don, can you show that drag and drop? I don't think many people are familiar with that. So.
Okay. So if you want to pick the third icon, the select tools from a library, and we'll just load. I have a couple of libraries already defined. And you can grab one of your tools from the tool library and just drag it and drop it here, or drag it and drop it into an operation that you already have working on up in your setup. So you can just drag it and drop it over there. And obviously I have all of these already over here, so it's asking me if I want to replace it, and I'll just say no. But that's how, if you don't want to keep your library loaded and bogged down in each of your files, you can open your library and grab a tool from it as you need it. So that kind of keeps your file lighter than it need, less heavy. Let's put it that way. So, and then also, you can save your tool library once you have tools in here. If you modify any of the tools, you can save it back out to your tool library. Okay, let's talk about knowledge bases in 3-axis. The cool thing about 3-axis and our plugins is that the plugin already understands that you have a geometry part displayed, and it already understands if you have a stock defined. Okay, so we're going to go ahead and just create some operations real quick. We're going to create a stock. We'll just pick a copy model bounding box stock, and we're going to go ahead and create a couple of a roughing and a finishing operation. Now, the two operations I'm using, they're present in every configuration. So whichever, doesn't matter what configuration you do have a base set of operations that I'm going to be pulling from. So you have a horizontal roughing. So we're going to go ahead and, as I mentioned, in 3-axis, you don't have to select geometry. If you don't select any geometry, RhinoCAM is going to automatically calculate the toolpath based on your part geometry and the stock that you have defined. So there's two requirements. You got to have geometry displayed, and it's got to be 3D geometry displayed, not a drawing. And you got to have your stock defined. So, and another thing I want to mention we're going to get talking about the defaults. Actually, I skipped that, and I'll talk about it here in just a moment. Is I mentioned that when you run the product or install the product for the first time, all of these parameters are set by default. Okay, so there's a value for everything. There's a value already defined for each of these tabs and each of the toolpath operations. So you can just go in and create an operation, pick generate without changing anything, and it'll calculate a toolpath and display it on the screen based on the default parameters that you have incorporated when you first install the product. Now, what happens if you go in and you want to change things? Obviously, you can change parameters and do whatever you want here. Change any parameter you want. So when you start making changes, you can generate it now or save it. Let's just go ahead and generate it. And when you have an operation, you can right-click on it and save as defaults. What that does is it allows you to select a name. You're actually creating a knowledge base here of defaults. So you can define a name for the knowledge base, and if you put it in the default path, it'll automatically be picked up in the CAM preferences dialog, and I'll show you that in a moment. So you can save that. You see I have that saved here already. So anytime you make any changes to an operation, you can save it out as a knowledge base. So if you go over here to the CAM preferences and go to the machining tab, you will see that you have a section called default machining operations and mop parameters. So when you first run the product, it will have one of these two options here. There's two options automatically already loaded. But when you create a defaults, you can save it out to a file in this same folder right here that's highlighted, if you see that folder. And if you save more default files to that folder, they'll be listed here in the drop-down when you display the CAM preferences dialog, and you can select a defaults file to use. If you don't want to select, or if you want to go back to the default parameters installed with the program, you just set it to undefined, and then when you create an operation, the default parameters that come with the product will automatically populate your operations dialogues. Okay, so we have a roughing operation. Let's go ahead and create a 3-axis parallel finishing. This is another toolpath that is in every configuration. And again, you don't have to select anything for geometry. If you do, by the way, select geometry, you can use that to contain your toolpath to a certain area. For instance, if I just wanted to machine just the cavity portion of this insert block, you could select the perimeter or the surfaces and it'll just put a toolpath on there. But I'm not selecting anything and I'm using all the default parameters. I'm just going to pick generate. So we have a roughing operation and we have a parallel finishing operation. Now we've got operations. This is just at a fundamental base level. Obviously, you're going to want to change your parameters and do other things, but we're showing you the level of automation that you can achieve in 3-axis with not much effort. So what we're going to do is we're going to save this out to a knowledge base. We're going to save to knowledge base, and then we're going to go ahead and save it. Let's go over to our program data folder. This is the path that was in the CAM preferences dialog that I showed you. And you can save this knowledge base or defaults file. I'm not talking about defaults. We're talking about the knowledge base itself. Save it to this file. I just have them all in one file. It makes it easier to work with. And I just saved it as 3-axis automation. Okay, I already have it saved, so I'm not going to overwrite that. But you can save that out. And the cool thing about knowledge bases in 3-axis is let's go ahead and just load a different file. And this works well for, files that are relatively the same type. So, obviously you're going to want to do a roughing and a finishing. So you can go ahead and just load your knowledge base. And one thing you do need to be aware of is you do need to have a stock defined to run the knowledge base. You can use the stock that's defined in the knowledge base, or you can just ignore it if you have your own stock defined. I'm just going to ignore the one in the knowledge base and pick OK. So it loaded the 2 files. Now you just have to regenerate. So the same operations were applied to this file, roughing and finishing. This was completely automated. Let's go ahead and do it with one more file. So we got another file here. We're just going to load the knowledge base. Okay. When you do ignore the stock, make sure that you have a stock defined in your part because you need to have a stock. And we're just going to regenerate. Let's regenerate it again. If you got any questions, put them in the questions panel and we'll get to them. So here it automatically applied your roughing and your finishing. All the parameters that you had defined in your original set when you saved the knowledge base gets applied to the part that you run the knowledge base on. And obviously you can go in and change any of these, save it back out to your knowledge base, and then you know, keep building and building your knowledge base in that way. Now, this is a level of automation. This is just a base level of automation you can do in 3-axis. Obviously, you probably going to want to select other geometry containments or whatever, but you can do this right at the base level automatically in 3-axis, regardless of what configuration you have purchased. This functionality is built right into the product.
So
Okay,
Don, there was a question whether the defaults are set per operation or as globally. I just wanted to emphasize that, you know, for instance, what Don had created here is a knowledge base that contains 2 operations, horizontal roughing and parallel finishing. So you can override the parameters of horizontal roughing, so that the factory default parameters for horizontal roughing in this knowledge base. So you can selectively choose to override. So he has not overridden any of the other parameters. So only in these 2 operations, he has chosen to override the parameters or have you know, specialized parameters for machining. So that's so you can choose what you want to machine and what you want to actually override in the knowledge bases. And the same goes for default knowledge bases as well. So hope that answers the question.
Okay. Okay, so let's talk about, we talked about 3-axis automation automatically. Let's go ahead and talk a little bit about, we talked about editing the knowledge base, and let's go ahead and we have a knowledge base tab here. Let's go ahead and load that knowledge base down here. You can take a look at it. So you can load your knowledge base down here. If you don't want to, when you load it up here, it's going to load everything in the knowledge base. So, so as your knowledge base gets larger with more files, you're going to have a lot of operations that's going to be thrown in there when you load it from the program tab. You can load it from the K-Bases tab down here and just drag and drop the operations that you want to use. So if you have a lot of operations in your knowledge base, you can just load it down here in the K-Bases tab, drag the operations up that you want to use, and regenerate them. So, and you know, that's a good way to use your knowledge base. I would recommend that you use it down here and just drag what you need. Otherwise, you're going to be deleting a bunch of things that you don't really want, just to get at 1 or 2 operations that you want to use. So use the K-Bases tab down here. Let's talk a little bit about using knowledge bases in 2.5-axis, and it's a little different in 2.5-axis versus 3-axis. Let's go ahead and load a part file, and I'm going to load this file here. Okay, so we have a flat pack. It's called a flat pack because these are flat components, and you can orient them, nest them in a flat sheet that you can cut in one sheet and proceed that way. I mentioned at the beginning that in 2.5-axis, you do have to select geometry. Any operation that you select in 2.5-axis, you have to tell it what geometry you want to use. So I have a knowledge base already created for this part, and I'm going to go ahead and load it. I'm going to load my knowledge base, and I'm going to pick flat sheet components with no selections, and I'm going to ignore that. So we have all these operations that I have defined in this knowledge base. Let me just collapse them all. So we have a drilling, standard drilling, a blind hole. We got some through holes, and we have some slotting. These are slots, and actually these dados right here are slots as well that we're going to machine automatically. And pocketing, these are for this area here. And chamfering, we got some chamfering going on around the corners, and obviously the final profiling. At this moment, if you look at each one, there's no geometry selected. So you can't generate it automatically in 2-axis at this point in the automation. And you can automate the selections. I'm going to show you that in just a moment. So even at this level, you can automate the selections. If you look over here on the right, I've got layers set up, okay, with all the geometry for these operations on these layers. So if you want to assign the geometry, you can just go ahead and go into the operation. You can pick your button to select geometry, and this is the standard drill 1/8 inch blind. So I'm going to pick the 1/8 inch blind, right click and select objects, and I'm going to right click and it'll add all our objects to the operation. Just going to generate. So you'll see this one was the blind holes. Let's go ahead and do the through holes. Select objects, right click, generate, and I'm just going to work my way through here. And this is the slotting. We got a slot layer, select, right click, generate, and pocketing. And again, this automation, I mean, you're building this automation in by putting the geometry on a certain layer, which allows you to easily select it and apply it to the 2.5 axis operation in your knowledge base. So we're doing the pocketing. So let's go ahead and select this one, right click, generate. So we actually have some pockets here for the counter bores. And let's do the chamfering real quick. And we're going to pick the chamfer, select object, right click, generate. And one last one, profiling, select objects, right click, generate. Okay, so we have all the operations, all of the geometry assigned to each of these operations in this knowledge base for this 2.5 axis part. Now let's step it up one level. You can automate.
Hey, Don, I want to interject and kind of summarize what Don's been showing here. I think the key takeaway here is number one is knowledge bases do not save geometry. They only save parameters
Right.
and in addition to that, they also save selection rules or logic, and that's what Don's going to be showing now. But the second thing that I wanted to point out here was obviously Don had organized his design in a way that selections were easy to be made. So in order for this kind of automation to be implemented in your shop, there is some work that you need to do to organize your data, on the design end. And once you do that, then that can also be done programmatically. If you have using Rhino programs, you can automate your design process and save things by color or layer. That'll make things a lot easier for selecting, like Don just showed. So those are two things that you got to keep in mind when using knowledge bases. Thank you, Don.
Okay, and again, you can make any edits to this. For instance, this is not sorted properly, so you can go in and sort those. You can make any edits you want, and then you can save this back out to the knowledge base. Okay, let's step it up one level for automatic selection of geometry. And I'm going to go ahead and delete my setup. I'll use the same part file. And let's go over to the K-Bases tab. And I'm going to go ahead and load a knowledge base. So I got other knowledge bases here. I got this one by layer and by color. Let's go ahead and select the one by layer. So it loads it down here. If you expand the folder for each operation, you'll see that there's an option called selection rules. And what you can do is you can double click on that and it'll open up a dialog that allows you to define the rules or the logic for what's going to be selected for this operation whenever it is present in your machining job and generated. This logic is going to go into effect. So
I think to make it a little bit clearer, whenever you load that knowledge base and you have these selection rules set up, it'll automatically pull those selections. So that's what it is. Yeah.
So in this particular knowledge base that I loaded, I have rules defined based on layer. So you see this drill 1/8 inch blind layer. This is the same layer that we used in the manual selection process. So we set this layer to this drilling operation. You can go and you can also define it by geometry, and you can use these and or operatives. For instance, if you want to select all lines on a certain layer, you can use the and function or function, and you can build your selections on top of each other. Right now I just have this set by layer for each one. Let's go and look at another one. So in this layer, standard drill through, we're using the drill through layer. So each one of these selection rules are set. So once you do that, you can just drag one operation up, or you can just drag the whole setup up, and you can generate it. Looks like we got a couple flags. Let's go ahead and generate that again. So it's collapsed so you can see this a little bit better. So what happened here is I set the selection rules down here in the K-Basis tab for this knowledge base. For each operation in the knowledge base has a rule based on the selections that it's going to automatically take. So once we loaded the knowledge base up here, and all we had to do was generate it. We didn't have to make any selections. You'll see that the toolpaths are already assigned to each of these operations. Now, I do have another one based on color, so let's go ahead and load that one based on color. And I'm going to go ahead and delete my setup. And if you look down here, the selection rules, you'll see that I have the color filters tab enabled, and I have a color defined. And you'll see that this color is the same color defined for that layer up here in the RhinoCAM layer. Okay, so it keeps everything standardized. It'll grab everything of this color. Now, regardless of what layer it's on, I have them separated by layers, but you don't have to. You can just have geometry in different colors. It'll grab the geometry for this operation based on this color. So we got that set for each operation type. You can drag just one operation or the whole setup and generate that. Let's generate it again. So here we got all of our operations done based on color. Because we got our slots, we got our dado slots, they're already done automatically. Everything is automated. So again, for 2.5 axis, what we did is we created 2.5 axis operations. We saved them to a knowledge base. After you save it to a knowledge base, you do have to tell it what selections are going to be made for each operation. You can just load that knowledge base up here under your the program tab, and just automate the selection by layers where we did, or you can load the knowledge base down here into the K-Basis tab and set the selection rules for each operation in the knowledge base and pick OK. Once you have your rules set, save your knowledge base back out. At that point, you can open another file, load your knowledge base down here and just pick an operation to use, or you can load the whole knowledge base up here and just regenerate all of the operations. So in 2.5 axis, this is just the highest level in 2.5 axis that you can automate, along with everything that we discussed underneath that, as far as default template files, cutting tools, etc. All of that can be built in to a level of automation that we achieved right here. So at this point, Joe, I'm going to hang it over to you so you can take the last 15 minutes. So let's go ahead and I'm going to go ahead.
Okay, so if you want to watch the answers questions window, I'll take over the presentation.
Mm-hmm.
Okay, so everybody can see my screen?
Yes, I can see it.
Okay. So what I'm going to be showing, so I'm going to be starting with the API or SDK. As I mentioned, when we install RhinoCAM 2023, the SDK will be loaded in this folder. It's automatically loaded. So if you look at program data, Rhino 7. If you go to the plugins folder, and then you go to RhinoCAM 2023, there's the SDK folder here. And under the SDK folder, you're going to have two folders. One is called doc, which is basically the API or the SDK user document. This is where all the documentation for the SDK is present. And you can go through this. It talks about, it's pretty complete. So you should be able to get started with it just by reading this. It talks about both the .NET framework as well as the Python interfaces. And it talks about the dependencies and how you want to set up, what are the tools you want to use for .NET as well as for the Python, and how do you set up the programs. It's got some code snippets that you can learn from. And then also it has a description of all the API methods that you can use. So it's quite comprehensive. And also I should state that this is not complete. The SDK is not complete. It's a work in progress. So we've started it out for a few methods, the more important ones, what we think is more important ones, and also based on user requests. And we keep enhancing this. So if you start using it and you have any specific requests, please send them in, and we'll definitely add it to the list of things for us to do. Okay, so what I'm going to show here is how can we program, using the SDK. And I'm not going to be showing C# in this because it's a little bit more complicated. But anything I do, I'm going to be showing it in Python. Anything that you can do in Python, you can do in C#. So typically, when you're programming, I like to keep the window, kind of split up into the Rhino on the left side, and then I have the Rhino edit tool. So if you want the Rhino editor for the Python, Rhino's got a pretty nice editor for Python scripts, and you can access it here under Tools. If you go to Tools and you go to Python script, you can say Edit, and that's what it brings up here. So what I'm going to talk about, I'm not going to be actually programming, but I'll walk through some of the programs that we have created. And that should give you a pretty good idea of how these programs are constructed. The most important thing for a RhinoCAM Python program would be the initialization. So actually what I can show is if you, these folders are, let me go back to the program files folder and the SDK folder. Let's go to Rhino 7, plugins, RhinoCAM. Then you go to SDK and you go to the examples folder. I didn't mention, I didn't go into this. So if you go to the Python folder, you're going to have a whole bunch of these examples that you get started with. So what I've loaded here in my editor is a few of these, just to give you an idea of how you can start constructing these programs. The most important one is the API initialization. So this is what I've loaded here. And you can just copy paste this. This is basically importing some of the libraries, the Python libraries the SDK uses. So if I'm going too fast, please stop and put your questions in the questions window, and Don, you can always stop me. Okay, so the next one I'm going to be showing is this operation. This one creates an operation. It's called mops.py. It basically creates an operation. As we have seen, this does the initialization in this section. And then it uses the tool manager and creates a ball mill. And this is the create ball mill tool that is basically using the SDK methods, and then is setting that as the active tool. And then we are using print statements here, which will actually come out here in the Rhino, command window as prompts. So you can put debug statements in there to figure out what's going on. So, okay, and then we're creating a parallel finishing operation. And then once the parallel finishing operation is created, we're actually modifying the tolerance. We're getting the tolerance and then modifying the tolerance to a certain need. And then we can finally regenerate the operation. So this is what, let me show you something. Let me load a file. Let me load maybe one of these files that Don was working with. So we have that file. It's got nothing loaded. So now I'm just going to run this program. So basically you can see it already created this parallel finishing operation, which wasn't there before. So, and if you can open it, if you go to the parameters, it should be 0.02. That's the intolerance that was set. That was set down here. So as you can see, this is a level of automation that you can, if you're always using a certain toolpath method, you can set it up this way and machine it. So let me run this again. So in case it went by too fast, I'm going to delete this operation. Let me turn the stock model off. Everybody can see the part. And all I'm just going to do is go and hit this play button. And that's going to create the parallel finishing operation here. Okay, hope that makes sense. And then one other thing I want to do, make it a little bit more, this is a little bit more advanced program. What it does, it kind of creates two operations, creates a flat end mill, and then it creates a roughing operation, and then it creates a ball mill, and then it creates a parallel finishing operation, and then regenerates both of them. And this is a little bit more detailed, and it's got more debugging statements, and it kind of also shows you how to do error handling. So in case a tool failed to create for some reason, how do you want to do the cleanup and exit? So there's a function here that shows how to do the actual cleanup. All of these need to be done in order for it to, these are good programming practices. Okay, let me run that. Let me load a different part. So I can, okay, we got a different part here. Let me turn off the stock model, and I can even delete these tool libraries. So I got no tools. So it's a pretty empty part. All we have is a design. Let's say we want to run this. So I'm just going to hit this, and it's automatically created those two operations, and it created the two mill end mills. One is the flat end mill and the horizontal roughing, and then parallel finishing. As you can see, if you once you create something like this and set it up, you can run this, in a repeatable fashion, and you can see the speed and efficiency you're going to, encounter in your shop floor when you do something like this. So,
Okay, Joe, that's a good point. We got a couple of questions.
okay.
One is the SDK specific to Rhino and not VisualCAM? Yes, you got to have Rhino.
Correct. That is correct. Yeah, it's only the reason we have done that. It's not available in VisualCAD CAM is because the SDK, the Rhino SDK, is very powerful. So you can do a lot of modeling things, and there's a lot of tools in Rhino that you can leverage, and which we did not want to duplicate in VisualCAD CAM or VisualCAD. So if one of our users is interested in actually doing automation using the SDK, we would definitely point them to the RhinoCAM product and not the the VisualCAD CAM product.
Okay, we also have another question. Where can designers go to learn more about how you can create the Python script with Grasshopper?
I think the Rhino itself, they have a lot of resources to learn about how to use Grasshopper and Python. Python is basically a very general programming language, and so you really don't need Rhino or RhinoCAM. There's many schools out there, many online schools or many online courses you can take in Python. But once you learn Python, get a basic understanding of Python, then you can learn how Python works inside of Rhino. The Rhino has a couple of things that you need to understand how to use Python. There's a thing called Rhino script, and Python interfaces with Rhino script. If you can see that some of these, I can show you where the Rhino script is being used. None of these use the Rhino script, but yeah, so there's a couple of subsystems that you need to learn. So once you do that, and then finally you have to come and learn what the RhinoCAM SDK does. So if you're just starting out, you got a long learning process. So but it can be done. It's not that hard if you have some kind of programming background. So hope that answers the question.
Yes, we got a couple of other questions that revert back to the knowledge bases. Maybe we got a few minutes, so I'm going to touch on a couple of them.
Okay.
There was a question about can you change the setup name when you load a knowledge base? If you set a setup name when you save the knowledge base, that name will carry over if you drag and drop the entire setup into the machining job, or if you load it directly into the machining job, those setup names will carry over. And then there was another one. How are the selection rules added before you create the knowledge base?
Actually, I answered all of those.
You already did that?
Yeah, already did that. And then, yeah, let's answer each question by section, because, that way it doesn't break up the flow, especially when we do the CAM jam. So, okay, so the last thing I wanted to show is, again, when we were talking about knowledge bases, Don showed how we can use knowledge bases, and he stepped up the kind of level of automation. One initial, basically loading a knowledge base and machining the part, just but one single button poke. And then he talked about loading the knowledge base and then using selection rules and logic that's built into the knowledge base. On top of that, I'm going to show what's you can actually create an SDK program using the SDK and then load the knowledge base and then regenerate all. This is what this one does. So basically, we're loading a file. Let me open a file. Just a standard file, let's say untitled. So I want to what this program does is does the initialization first, and then it loads a file, and then it loads a knowledge base here, and then finally does a regenerate all. So let's run it. So you can see it takes a little bit of time, so it loads it and it's finished. So this is exactly the same knowledge base that Don was working with. So this is this level of automation. You're not even loading a part manually. You can program all of that. Let's say you have a bunch of design files that your designer is sending you. You can put them on in a folder and set up a program that runs through each of those files, loads them, applies to knowledge base, and generates the toolpath. So it all can be automated that way, and that's a very powerful technique to use in your shop floor.
Yep.
Okay, so that gives you an idea of some of the functions in our knowledge base. There are addition functionality. You can set up tool libraries, edit tools, edit operations, post-process, load post-process, and do a lot of other things that you normally do manually in our system. So that's why that's a quick overview of what we have in the SDK. Any questions there, Don?
Nope, we're all set for now.
Okay, I'll jump into Grasshopper. We're not going to too much into we're not going to go deeply into Grasshopper. I'm just going to talk about Grasshopper a little bit. So I'm going to get out of this editor. So I've set up. Let me load a new file. Okay, what I have here on the right side, for those of you who are familiar with Grasshopper, you know what this is, but those of you who are not. So this is actually the Grasshopper programming interface, and you can access this by going to Tools and going to Grasshopper, or just typing in Grasshopper in the command window in Rhino. And you can set up different nodes or widgets here, and you can programmatically set these up so the output of one widget goes into the input of the other, and so on. So what I've done here is I've set up 3 nodes or 3 widgets, if you will. One, I'm calling it CAD, and then its input to this is a drop-down list, a drop-down control. So basically, there's 5 different values in this drop-down control that the user can use. So basically, you can think of it, I'm kind of simulating the parametric design part of it. So, and this CAD component, what it does is it takes this input, this drop-down input, which can either be 2 through 2.5, 3, 3.5, or 4, and creates a circle, a very simple circle. So let me bring up the file. So this is actually this component actually is what's called a GH, Python script using the Rhino API. So it basically, if you look at the code here, you see this variable called radius in this node, and that's what we get. That's the input to this. So we're assigning a radius and creating a circle, and then we're adding that circle into the Rhino database, and then we are getting the ID of that circle and assigning it to this variable called geom, which is nothing but geom here. This geom that shows here. So close, let me do that. So this geom, I don't know what that is doing. Okay, so now let's look at that. That geometry output is then passed into this CAM component, and let's look at what CAM component does. So this one uses the RhinoCAM SDK. So basically it pulls in the geometry, which is in this case is going to be a circle, and then it creates a 2.5 axis pocketing operation. Mill tool creates a mill tool, and then it populates the operation with that selected geometry, which in this case would be the circle, and then it regenerates the operation. And then once that's done, it's going to post it using a post. Let's see what this one does. So that operation is sent in as input to this widget, and then this one takes and creates a post using a post process, selects a post and does a post processing operation. As I mentioned before, it's always a good idea to keep these two panels side by side like this, so you're showing you know what you're doing. So let me show how this whole sequence works. So as part of a parametric design, let's say you're creating a circle of three radius. Radius is 3 inches. So it went through these components and created the toolpath and posted the output out. So, and it also created the toolpath here. So now let me say I want to do a 4-inch circle. So this, I shouldn't have selected that. So let me delete that. So I got deselect everything. I'll do the 4-inch. Let me do a 3.5. There you go. Deselect. Do a 2. So as you can see, this is how now we got parametric machining, if you will. So I'm basically creating these circles parametrically by just creating, inputting these parameters for radius. It's a very simple example, obviously, but then you can set up any complicated relationships in the back end to design more complicated shapes. And then you can drive it to something like this. We're creating the geometry, and then you pushing the geometry into our CAM component, and then finally posting it out. So this is a quick example of what you can do using Grasshopper, not only to take the power of the Rhino part, but you can also use the SDK as well as the posting capabilities in our SDK to create different components. And there's other things you can do here. You can load files. You can, in fact, in our company, what we do is we do regression testing using Grasshopper. So basically, we load files, all the test files that we have. We load files automatically and regenerate the operations that they have. We load knowledge bases automatically and regenerate and then check the output. So that kind of level of automation you can also implement in your shop based on the kind of parametric designs that you're working with. Hope that makes sense. Do we have any questions?
Nope, we're all done with questions.
Okay, that's interesting because this is the most complicated part. So maybe it's people need some time to digest this. So, okay, but we are always open to questions. You can always drop them in our support at MecSoft.com, and we'll try to get to those questions.